All right, so we got to this question here. What did we say? We want to determine a domain and find critical values, B, right? Domain and critical values. So quick question on domain. Is there any value that I can't plug in? No. No. No, everything's good, right? No negative exponents, so nothing goes to the bottom, no radicals, right? Yeah, so the domain's all reals. How do you want to take a derivative of this? How do you want to take a derivative? So Brandon suggests product rule. Okay, I could. Can I distribute that? If I did, what would I have? I'd have that minus x to the first and 3/5. What's the first power plus the 3/5? It's 1 3/5, right? Which is 8/5. So to me, that seems like a pretty, oh my God, why can't I draw an 8? There we go. To me, that seems like a relatively simple way to take something that would be a little bit more complex and ease it up a little bit, right? Now it's just power rules, right? So my derivative is going to be 12/5 x to the negative 2/5. Right, doing a lot of fractions in my head, but minus 8/5 x to the 3/5. All right, so I got that. Again, what do I know, guys? I know that I want this derivative, right, to find critical values to equal 0 or not exist, right? So I'm going to rewrite this, and that's one way I could convert these to. I could convert these to fractions, right? Or do you remember Austin a couple days ago? Well, not a couple days. Thank you. Not bad, right? Oh, perfect. That's a good start. Remember a few, I'll say probably lessons, maybe like weeks ago, we talked about factoring out a least power, right? Factoring out a least power. And that would be a method that we could use on this one. If I was to factor out the least power, what's the smaller of the two powers? The negative 2/5. So if I factored that out, what would I have? I'd have 12/5 minus 8/5. And if I factor this out of this, what do I get? Well, what am I really doing, guys? I'm taking this and I'm dividing it by this, right? So what's 3/5 minus negative 2/5? 1, yeah. Yep. And so again, that problem right there doesn't become an issue in do I know how to take a derivative and do I know what to do? It's an algebra issue, right? Now, what am I going to do with these two things? Well, can they ever, actually, let's rewrite it like this. Let's say that we have 12/5 minus 8/5 x over x to the 2/5, right? So I just rewrote it as that. Is that okay if I do that? Seem reasonable? Yeah. B, what do we know? Well, the derivative doesn't exist when this equals 0, right? Well, what value makes this equal to 0? 0, yeah. So I know that I'm going to have a critical value at x to the 2/5 equals 0, so that's 0. And at, I'll do it down here, and at 12/5 minus 8/5 x equals 0. And that's going to give me x equals 3/2. All right, so again, guys, right, the thing with this becomes more about the algebra in that, right, than anything else. B, you agree? Yeah. Are we okay? Flip the page. We're gonna skip over this. We could do a really cheesy example. We're not gonna do that. All right, Austin, we're gonna kill it today. Ready? Here's what I want to do. I want to know if the extreme value theorem applies. So we said yesterday that the extreme value theorem applies when f of x is continuous on a closed interval. So my question, does the extreme value theorem apply? Is this a continuous function? Yeah. Is this a closed interval? Okay, so it definitely applies. Okay. Now it says, if so, find the what? Find the extrema. And what did we say yesterday? We said that, or 2 days ago. Did I see you guys yesterday? Friday. So what did we say about extrema? We said extrema can occur when derivatives equal 0, derivatives do not exist, or at the endpoints, right? So those are my possible extrema, okay? Well, I have 2 values, right? And wouldn't these 2 values be where the endpoints are going to happen? Okay, well, shouldn't we figure out what those values are? So what is, oh, by the way, we called endpoints critical values, didn't we? Yeah. So we have critical values of f of -1 and f of 2, right? Those are my endpoints. All right, what do we get? Well, we plug in -1. We get 3 times, what's -1 to the 4th? 1. What's -1 to the 3rd? -1. So this is -12 times -1. So that's 12. That's 3 minus 12, -9. That seem okay? Did I mess that up? You all looking at me weird. Oh, sorry, negative plus 12. Plus 12, sorry. 15, got it. All right, plug in 2. 2 to the 4th is 16. 16 times 3 is 48. Minus 36? No. 96, minus 96, 36, 40, -48. Somebody check that for me. I'm pretty sure it's -48. Go ahead, Evan. I want to really make sure. While he's checking that, okay? While he's checking that, I need the other critical values, right? Did I get it? All right. I need the other critical values, right? So when am I going to find those? I'm going to find the other critical values by finding my derivative. So my derivative is 12x cubed minus 36x squared. All right. Is there ever going to be a chance ever in the world when that is going to not exist in terms of finding derivatives? No. So the only thing we're going to have to worry about is when the derivative equals 0. So we got a little factoring to do, right? I'm going to take out a 12x squared. And what do I get? I get 12x squared equals 0. And I get x minus 3 equals 0, which means we have critical values at 0 and 3. So 2 more critical values. F of 0 and f of 3. But what does the really, really observant student notice right now? The really, really observant student notices that what? 3 is not within the interval. So even though it's a critical value, it's not a critical value within the interval. So we're not going to worry about that one. Plug in 0, what do we get? 0. So guys, without even looking at the graph of this, what do we know? We know that this is a what? Well, it's a critical value, but which critical value is it? The negative 48. What is it? It's an endpoint. It's also a what? Extrema. Which extrema? The absolute min, the global min, right? There's no point on that graph that's going to be less than this. Agreed? Right? Yeah. So the global or absolute or just the word minimum has got to be at f of 2 equals negative 48. The global max. What's the global? Well, you said negative 1? At 15, yeah. Yeah, f of negative 1, all right? This is the biggest value. Cool, right? So we just found the two absolutes, right, by doing that process. Is that cool? Okay. Does the extreme value theorem apply? Continuous? Yeah. Closed? Yeah. So since f of x is continuous on the closed interval negative 8 to 1, the extreme value theorem applies. Which means if I can find all my critical values, I can figure out my extremes. So again, I know I have critical values at the endpoints. Now let's figure out if we have any others. Derivative is 2 minus 2x to the negative 1/3. Because what do I do here? What's 3 times 2/3? 6/3, which is 2. And then 2/3 minus 1 is negative 1/3. Can I make that look a little prettier? Yeah, I'm going to rewrite it like this. How am I going to solve this, guys? Well, do you guys agree to do this? I need to have like one fraction here. So I need a common denominator. Right now, this is over 1, right? So if I made this the same as that, I'd have to put one of these on top, right? So would you agree to rewrite it? I could say it's this. Same thing, right? So what does that give me? That gives me 2 cubed roots of x minus 2 over the cubed root of x. Again, Evan, not so much about the theorem, right? Theorem's pretty simple, right? What am I going to do? Find my derivative. Where does it not exist? Where is it equal to 0? What are my endpoints? And now I got all my possible critical values, which gives me the extrema. Make sense? Right? I mean, that seems reasonable, right? All right, well, what happens here, guys? I want to see if that can equal 0. So I'm going to add 2 and divide by 2. If I add 2 and divide by 2, what's that going to give me? It's going to give me 1, right? The cube root of x equals 1, which means x had to be 1, right? Can't be negative, right? Yeah, because the cube root of a -1 would be -1, right? And then I got the cube root of x equals 0, which means it does not exist, right? And what value does that occur at? At 0. Okay, so it just so happens that one of the critical values occurred at the endpoint. So it's just coincidence, right? That's all. All right, so I got to add f of 0 to the mix now, right? All right, plug in 0. Okay, guys, where am I plugging these in right now? Back into the original, right? And I'll give you the values, guys. If we plug in -8, we're going to get -28. If I plugged in 1, we're going to get -1. And if I plugged in 0, we're going to get 0. So what do we know? Well, we know that we have an absolute max and an absolute min at, where's the min? F of 1 equals -1. And, oh, sorry, wrong one. Hang on. At f of -8 equals -28, right? Smallest y value. And then the max would be at f of 0. Seem okay? Right? Okay. Does the extreme value theorem apply? Because what is it? It's some combination of sines and cosines, right? But there's no values of those that are undefined, is there? Not talking about a tangent or a secant or anything like that. And do I have a closed interval? Yeah, so we can do it, okay? So we're good. So critical values. Well, we know we're going to have to do f of 0. We know we're going to have to do f of 3 pi over 2. What is 2 sine of 0 minus cosine of 0? I'll wait for somebody to give it to me. Close. What's this? 0. What's this? 1, but what was in front of it? -1. All right, 3 pi over 2. What's sine of 3 pi over 2? Close. -1 times 2. -2. All right, and then if I double 3 pi over 2, what does that give me? 6 pi over 2, which is 3 pi. And what's cosine of 3 pi? 0. Good. 0. 0. So this is going to give me -1. It was, so we plugged 3 pi over 2 in, right? So this is equal to -2. And then this was equal to, oh, wait. Oh, -2. Not -1. Thank you. That was a close call. All right, what else do we need? The what? Derivative, right? All right, derivative of 2 sine, 2 cosine. What am I going to have to do with this one? Chain rule. What's the derivative of 2x? So I have minus 2. What's the derivative of cosine? Negative sine of 2x. So what is that going to give me? It's going to give me 2 cosine of x plus 4 sine of 2x. Minus, oh, sorry, it shouldn't be 4. No, that's a 2. Plus 2. Yeah. Guys, if you get to this point, you would have done a really, really good job, but you got an issue. And the issue that you have is that I need to know what? I need to know where this equals 0, right? And you see how you might run into a roadblock, right? How are you going to solve this? How are you going to solve this, right? Well, the only way to solve that, and again, this is what separates the 95% and the 67% who both get 5s, right? They both get 5s, right? But this is one of those identities you got to know, okay? And the identity is this. It is that sine of 2x equals 2 sine of x cosine of x. It's one of your trig identities. And so the only way to finish this problem would be to substitute. How would you? Give me your thought. Maybe you could. Maybe you got away. Well, it's because the only way to set this equal to 0, I would look for a GCF, right? So I would do this. And now what? Now I would set this equal to 0. It wouldn't get me anything. I would try to set this equal to 0. And you know what I mean? Yeah, I'd be back at the same spot. So this is why I would have to have the identity that sine of 2x is equal to 2 sine of x cosine of x. And that gives me what? Now I can take a cosine of x out of both of those, right? Is that cool? And now I can set both of these equal to 0. So this gives me cos of x equals 0. And this gives me sine of x equals negative a half. All right, so now you got to close your eyes and you got to picture that cosine curve. And where does that cosine curve equal 0? At 3 pi halves and at or unit circle. Right? Guys, if you got this is like one of those things that you just gotta at some point memorize, right? Boom. All right. So which one of these values represents the cosine, the x or the y? The x. Yeah. So where is x equal to 0? Here, which is at 90, and here, which is at 270. Right. So pi over 2 and 3 pi over 2. So you got to know the unit circle, right? You also got to remember this thing, right? Right? The 1, 2, 3, 3, 2, 1, right? So I want to know where sine, oh, the other thing is this. Right? Okay, so I need that thing. Okay, so from 0 to 3 pi over 2, so I'm only allowed to look where? This quadrant, and this quadrant, right? Which one of those quadrants is my sine going to be negative? Well, not here and not here, so I got to be in this quadrant, right? Okay, and now where is sine equal to a half? Well, it's when I have a 30-degree angle, right? So if I have a 30-degree angle in here, right? Give me 30 degrees in radians, pi over 6. So if this was 6 pi over 6, then this would be 7 pi over 6. Right? So trig is important, right? You got to be able to do a little bit of trig here. So do I have all my critical values? Well, yeah, I had the 0, I had the 3 pi over 2. Now I got to add which ones? I got to add the pi over 2 and the 7 pi over 6, right? So add those. And I'll give you those. You're going to get 3, and you're going to get negative 3/2. Okay. And so which one of these is the highest one? Bang, there's my max. And where's my min? There's my min. Absolute min, absolute max. Okay. Ivan, what if I don't give you an interval? Then the extreme value theorem, what? The extreme value theorem doesn't apply, right? And the extreme value theorem says that if I have continuous function with closed endpoints, there has to be a max, there has to be a min, right? Okay. Well, if I don't have that, then could there still be a max and a min? Yes, it just doesn't guarantee it, right? It just doesn't guarantee it. So I still might, just not sure. Just not sure. Now, part of what we can do, guys, is we can actually think about these things by just sketching some quick curves, right? I just want to sketch some quick curves. So guys, do I know right now what this looks like? If I asked you guys, graph it right now, could you? No, but believe it or not, you actually can. Because what do you know about a fraction? Well, the bottom can't be what? Can't be 0. And what do you know about a radical? The thing underneath can't be negative. So what do you know about 4 minus x squared? It's got to be positive, so it's got to be greater than 0. So the 4 minus x squared has to be greater than 0. Now, guys, we could make a national case out of this, or we could make this really, really simple. Because I'm doing this right now with my Algebra 2 class. If I rewrote it, I could rewrite it like that, couldn't I? And if you did a CBAD transformation, what did I do? I took a parabola and I flipped it vertically and I shifted it up 4 units, right? So this is a parabola that's been flipped and shifted up 4 units. So it looks like this. Now, what did I say about my function? In order for this function to exist, I have to be values where? That are greater than 0. Well, where are these values greater than 0? Aren't all those greater than 0? And on what interval does that exist? From -2 to 2, right? So this graph only exists between -2 and 2. Everywhere else, this graph is what? Undefined, or isn't there. So what do we really have, guys? We really have a graph that is bounded here and here. Right? Do you guys agree that it's asymptotic there? Because if I plugged in those values, what would I get? I get 0. Okay, I get 0. Say it again. Okay, good. So, awesome. What's the shape, right? What's the shape? And that's what we got to figure out. Well, here's what I do know, right? Brandon, I do know that this graph only exists in here, right? So what I'm going to do now is I'm going to what? I'm going to take the derivative of this and see if there's any extreme values that are between -2 and 2, right? We're going to see what happens, okay? So let's take our derivative. Now, guys, again, I want to make my life easier. So am I going to really use a quotient rule here? No, I'm going to rewrite it as 4 minus x squared raised to what power? The -1/2. You guys are smart. Now, what does that require me to use? Chain rule. Okay, what's the derivative of the inside? -2x. All right, what's the derivative of the outside? Well, the -1/2 comes in front. This stays. And 1/2 minus 1 is -3/2. All right, well, what things happen here that might make this a little bit easier? Well, that 2 and that 2 reduce. And what's left? Well, I have a -1, so I have a 1 over the square root of 4 minus x squared to the 3rd power. That's my derivative, right? Okay, so here's what I got to figure out now. Is there any way that this derivative can equal 0? No, not probably. The only way that a fraction can equal 0 is if what? The top equals 0. Well, what's the top? The top's 1. So no. Is there any way the bottom of this can equal 0? Well, we don't want it to. Well, we do want it to equal 0 because that tells me when the derivative doesn't exist, which gives me a critical point. So what value can I plug into this that gives me 0? 2. What other value can I plug into this that gives me 0? -2. Oh, okay. Well, those happen to be the asymptotes, right? So are there any critical values within that? Oh, guys, I made a mistake. Actually, it's a quick one. It's a quick one. Are there any extreme values in here for the bottom? Well, the 2 and the -2, right? But what do I know about 2 and -2? They're the asymptotes, right? So are those going to give me turning points? No. Here's the mistake I made, and it's kind of funny. We said we were going to cross out the 2 and the 2, right? Well, what do we have left there? Yeah, you do. the x. You see it? Yeah. So it can equal 0 after all. Yeah. So we do have a critical value at f of 0. So if I plug in f of 0, what do I get? I get plug in 0, that's a radical 4, isn't that a half? So f of 0 equals a half. So that means that at 0, I have my graph hit this point. And that must be what? Either a global max or a global min. Oh, actually, it may not be global. It could be what? It could be relative, right? It could be relative. So it's either, it could be global, it could be relative. Here's my issue. How am I going to figure out the rest? Just give me a really easy way. No. Give me a really easy way, Brandon. Plug in. Plug in 1. Plug in 1. So what do I get? Plug in 1, I get 1 over radical 3. So I get a positive number, right? Okay. Some positive number. Do you guys agree with that? What if I plugged in negative 1? I would still get what? Some positive number. Oh, guess what? Well, if this number is below, or if this one's below and this one's below, then this had to have been a local max. Were there any more extrema? No. So will this graph ever turn again? No. So I know that my graph has to look something like that. Has to. Has to. Isn't that cool? Right? Isn't that cool? So we didn't do a ton of calculus there, but we did. I mean, we really talked about a lot of different things, right? We talked about why these asymptotes exist, right? We talked about how the derivative gives us that value. All right, how would I do this one? Well, again, I want to know where the extrema are. So again, where are the extrema? The extrema exists when the derivative equals 0. So what's the derivative of this? Well, what's the derivative of the top rule? Negative 4x. And that's when x is less than or equal to 1. And what's the derivative of the bottom rule? 1, where x is greater than 1. So can this derivative ever equal 0? Well, yeah, when that's true. By the way, you got to make sure that what? That this fits within this, right? So does 0 fit within the rule? Is 0 less than or equal to 1? Yeah, so this is, right? This is some value of critical importance, right? So it's a critical point. At f of 0. Okay. Hey, one more thing. Is there any other value that would be critical here? Because remember, critical values exist when what? Derivatives equal 0 or derivatives don't exist. Where would the derivative not exist? At 1. Why would it not exist at 1? Because if I plug 1 into this, what do I get? 3. If I plug 1 into this, what do I get? 3. Oh, actually, hang on a minute. Okay, but here's the issue. In order for a derivative to exist, the graph has to be continuous at the point. Is the graph continuous at the point? Yeah, because what did I get for both of them? 3. But what's the other piece that has to be true? For the derivative to exist, the derivative from the left and the derivative from the right have to be the same. So what's the derivative from the right? 1. What's the derivative from the left? Negative 4. So do we agree that the derivative doesn't exist at 1? All right. Now, if we had to write all that down, we could. Okay. So our critical point is at f of 1 and f of 0. All right, and this one is where the derivative does not exist. Okay. Plug in 0, what do we get? Where does 0 get plugged in? It gets plugged in here, right? And I get 5. And plug in 1, and where do I plug in 1? Well, I plug it in here, and I get 3. So what does that mean? I have a local max at here and a local min or absolute. We don't know which one, but one or the other, there and there. All right, last problem. And I'll do this one relatively quickly, guys. This is going to be all calculator, okay? This is going to be all calculator. It says use your calculator's equation solving skills to find extreme values, right? So what do I need to know? Well, I want to know this and this to get my endpoints. So I'm going to put this in the calculator, save it as f of x. Well, this is working well, or not at all. There it goes. Guys, you're going to want to use this function, I think, when you're taking your test. It's nice to get things in quickly, especially when you have these multi-part problems. All right, got that. So I want to know the two critical values that we got so far, which were 1 and -1. All right, good, got those. What else do I need? Got to know my derivative, right? Guys, I've never tried this before, but I'm gonna. I'm a little nervous. Ready? Algebra and solve. I want to know where the derivative x. Oh, I can't do it this way. Can I? No, can't. That stinks. Okay. So be it. We got to do it by hand. Talk to me. Take this derivative by hand. Ready? What do I have to do with this? It's a product rule, isn't it? Yeah, this is a product rule. So I have my I have that, right? Derivative of x. Oops. Derivative of x. 1. Derivative of v is a chain rule, isn't it? Because the exponent is differentiable. So what's the derivative of -x? -1. And what's the derivative of e to the x? E to the x, right? The derivative of e to the x is e to the x. In this case, e to the -x. That's my derivative. I already dealt with that -x by using the chain rule, didn't I? So what's the derivative of that first piece? It is 1. What's that? Or that. Say again? Oh, yeah. -2, right? Yeah, I don't want to forget about the -2. Now, guys, here's the thing, right? What does this represent? That's the derivative, right? So what am I going to do? Again, if I got a calculator at my disposal, won't I just plug this into my calculator now, right? All right, so now let's go back. So now I want to find roots. I could do it this way. Why don't we just do it this way? Let's do it as an unsolve, right? Because I want to know where that derivative equaled 0. So what did we have? We had e to the negative x plus, or no, it was minus x e to the negative x minus 2. And I want to know where that equals 0. Oh, what do I got to do? Comma x. Thank you. Comma x. Boom. Okay. Again, what does this represent? This represents the other critical point, the other critical value, right? So now what do I want to do? I want to find f of that. And this gives me the other extreme value. So what do I have? Well, I have a absolute min, absolute max. Isn't it impressive? It's kind of cool, right? Now, again, by doing all that, guys, what am I doing? I'm getting key features of a graph that I'm not looking at, right? But I get those turning points, and we'll see why that's important as we move on through the course, okay? All right, good job.